I thought I'd make another video. I had a couple of requests for actually how to zero up stock in the vise and how to locate and re-zero your part as you're flipping it around. And I really didn't do much video on making that part in the last one because it takes so long. And I spent about an hour this morning trying to figure out what I was going to do and get it all in order so I didn't sound like an idiot, but it's hopeless. I'm just going to sound like an idiot and we're going to get it done. I'm not much of a public speaker here. I want to show you first off how I would actually find the 0, 0 on the block, and I'm going to zoom out a little bit on this camera. Your 0 point, let me zoom here. Your 0 point can actually be wherever you want to start from, and all measurements will come from there. It could be back here on the corner. Most of the time it is on the lower left, but it can be any one of the 4 corners. And even though your part may be of odd shape, you still have to set up a 0, 0 point, and that odd shape is actually in reference to that. So even though this is an odd shaped part, where it originally starts out is a 0 point in the XY plane. Its height is its 0 point in the Z plane. So no matter what the shape of the part you're working on is, it's in an imaginary cube, you know, where X and Y and Z make the actual dimensions of that cube. So to find that 0 point, I'm going to work off this edge just because it's easier for you to see. And we have all kinds of edge finders. I don't know if you can see these. Let me get my hands up here. I don't even know what dimension this is. No matter how much stuff I set out here. Some of this stuff's metric, some of it's standard, most of it's Chinese. All of it's Chinese. Okay, that's 2/10. And then this one is an electronic edge finder that as soon as it touches the edge it actually lights up, and it's 2/10. These are for finding like centers of small holes or center punch marks in your actual stock, and I have a couple of different sizes of them. These are useless if you have collets. If I've ruined 2 of these so far. If you try to shove a double-ended edge finder in a collet, when you try to get it back out, the one end will actually stick in a collet and you'll stretch the spring. So if you've got a double-edged edge finder, I would be really careful trying to take it in and out of a collet. I've had a lot of trouble with these, so I prefer not to use the double-ended ones. So that's it for edge finders. And since NASA hasn't called for me to go to work for them, I don't use these. I have a I don't know if you noticed it in the photographs, and I'll move this down so you can see it. Hopefully it'll come into view. Most of the stuff I do isn't really all that accurate. If I'm within a few thousandths, that's fine. And most parts that you make, there's only a few areas of the entire part that are actually critical measurements. And an example of it would be the part that I made just here recently. And actually the critical measurements on this part are, 1, where the 4 bolt holes are located here. Alright. 2, the distance from where this actually bolts down to the motor to the center of this hole, and how far apart the center of these 2 holes are apart from each other. The size of the actual hole, because that's a fit pin. But as far as the physical shape of this part, those are not critical dimensions. If they're off 5/10 thousandths, it's not going to affect the actual utilization of this part. So I mean, you can pull your hair out trying to be overly accurate with things. I mean, there's times to be dead nut on accurate, and then there's some stuff that you can, as long as you got it all in your head right when you start, you can get it straightened out. But if that makes any sense, to locate zero, I'm going to zero this corner, and the way I do it is Mach 3 has what they call step mode, which if you set it in 1000 step mode, each time you hit the X or Y button, the axis will move 1000. So what I do is I turn my mill on, and this is actually it's a gauge pen. It came out of a box of junk I had. Tony commented that he was cringing because I was using a gauge pen. I just take the indelible marker and mark the gauge pen. And if you look, it's not perfectly straight, so I probably ought to take this out of the collet, clean the collet, and put it back in. But for these purposes, let's imagine that's perfectly straight. I'm going to move it to the general location to measure this edge right here. So I'm going to move back. I'm going to move down. Oops. I hit my light. Alright. Now I'm actually going to slow my feed rate way down till I can gradually just move it over there real slow, and then I'll switch to step mode. I kind of went too slow. I don't want to rush on these. If I have to make a few videos to do this, I'll do it. Because a lot of times this is stuff that... Okay, now I'm going to actually put Mach 3 in step mode in step 1000ths at a time. And the block's going to move towards the pin. And as soon as I see it touch the ink, I'm going to zero the x-axis. Hopefully you can see this. It'll all of a sudden make a shiny spot on the ink when it touches. Getting close. There it is. Now, see if I can zoom in, and you can probably just barely see it starting to shine here. See the shiny spot on the pin. Okay, that pin's exactly a 1/4 inch, 0.250. So to zero that, I'm now going to take it out of step mode, back into continuous speed, speed it up a little bit, so I can raise it up. And unfortunately, I can't show you display Mach 3 at the same time because that would have took an extra camera feed. And so you just have to take my word for what I'm doing in Mach 3 itself. I have Mach 3 running on the computers I'm video on as an example, but I can't show you the one that's actually hooked in a machine, and I wasn't going to install all this software on that computer. So now at this point, I'm going to hit 0 on x-axis in Mach 3. Then I'm going to move the block towards the pin 0.125, half the thickness of my 1/4 inch pin here. Go to step mode because I only got to move 1 more thousandth. And once I have 0.125 reading on X, then I zero that axis again. So now that is directly zeroed over this edge right here. So now I'll move back, speed it up a little. So take it out of step mode. It's only moving 1,000ths at a time. Try that again. And slow it back down. Drop it back down. Move the block a little closer to the pin, so when I start stepping, I don't have to push the button so many times. down a little further. I'm just going to touch ink to my pin again. Now, of course, this pin would have to be straight. Like I said, I wasn't while I'm videoing this. I'll give that just a second to dry. And I'll start, move it just a little bit my way. Go back to step mode. And start stepping the block towards the pin again until I see it shining. And I'm only moving 1/1000th at a time. Right there, it just started to touch, and actually I would zero right there, but you probably can't see it. I don't know if you can see it in the video or not. Oh yeah, it's showing up. Okay. I'm going to take it out of step mode now. Raise it up. And then move zero my y-axis, and then move the block under the pin, the radius of the pin, 0.125. There's 125, and once I have that reading, then I zero y. So now, if I type in x0, y0, that pin will line up centered right above that corner. And I don't know if you can see it from the angle of the camera, but the pin is dead center right over that corner. Now, it's whichever corner you pick that you do it with. And you can do this with an edge finder, you can do it with whatever you decide to, but that's how you actually find whatever point you're using as zero, how I do it. I never had a mentor. Everything I know about what I'm doing right now, from CNC to using any of these tools, I learned off the internet, so I didn't take any courses or anything. This is all just looking at pictures. Okay, so from this point here, let's say if you wanted to set up your machine so that you could do a lot of different shaped parts and you didn't want to have to re-zero every time. Let me take it out of step mode. Go to continuous, raise the up. If I had several pieces that I was going to work on, and I did not want to have to zero every piece, and they're all different shapes, the way I would set up my machine is I would zero off the fixed jaw on the vise and the stop on the vise. Oh, for all you guys, there's no way I would have clamped that piece of material in that way. That was for visibility purposes. Whenever I post something, I always got somebody that comes back with something about how I'm doing something wrong. I appreciate it, but okay. In this scenario, what I would do is actually bring Z down, Y forward. So I can get some light in here. And I've set up a stop in my vise, which I hope you can see. You can see the stop in the vise right here. And then I want to zero off the fixed jaw of the chuck and the stop. Okay, I'm not going to go through all the trouble of zeroing it. I would do it exactly the same way as I did the other corner of the piece I had up here originally. But the point of this is, once that machine is zeroed in on that, and you're working with various sizes of different sizes of square stock, as long as you're drawing and your measurements all are figured off zero this way, from this corner, then all your measurements are negative down this way. I'm sorry, I probably screwed that up, but are from that corner this way, if that makes any sense. So let's say if I had a piece of stock like this, now when I put it in there and chuck it up, this corner now, if this was perfectly square, this corner now is exactly zero. If I had a different piece of stock, no matter what the dimension, this corner now is 0, 0. So obviously it makes sense that no matter what I put in here and run it up there, I don't have to re-zero each piece of metal that I'm putting in here each time, because I've zeroed off a fixed position instead of a changing position, which would be the other jaw. And I have a stop here that as long as I don't bang it and knock it out of position, each one of the pieces of material I put in here is still going to be zeroed off of that, and all of its measurements will come off of that. Let me go into, let's see, odd shapes. Let's go with odd shapes now. Let me find it. A lot of people don't know that the vice handle fits these on a ZX45. It also fits your to release your collet up on the top. I'm having this is a problem with me. I can't talk. My brain works, but my mouth ain't connected to it. Okay, let's go into working with different shaped objects, and say, for instance, squaring round stock. There's different ways of doing it. You can obviously you can go get a square. Find a square. This one's probably too tall. I thought I had everything sitting over there ready. Okay. You can go like this off your actual vise and come in here and square up your stock. If your stock was actually trued up in a lathe and not saw cut, it'll sit in your vise straight. And if it's a little small, you can clean a parallel, a little smaller than its diameter, and set it on it. If it was actually turned, if it was faced in a lathe. And like I said, you can come in and square it up this way. That's okay if you've really bought some expensive machinist squares, which I don't have. One of my lists of items I'd like to buy. But I would square this a little differently, and I'll show you how I would do it. Now, a lot of you guys jump in. I know there's so many different ways of doing things, and you know, I'm by no means am I showing anybody anything that I'm saying is the right way of doing something. The way I would do this, though, is with a gauge, dial indicator. I just kind of center up with my axis, drop it in from the top. If I can move this camera into position here. Yep. Alright, let me see if I can move this camera. I don't know if you can see the indicator. I need to put a little more tension on this Chinese indicator here. I'm going to go around. And I'm not actually trying to hit a 0, I'm just trying to hit a fixed point. Close enough. And all I'm looking for is no variation as I go up and down. So I just run my Z down, it doesn't matter what distance. The longer the distance, the straighter the part. Now as you look, you can see that I'm not square. I'm definitely leaning. So what I would have to do in a case like this, just take a small mallet, have a little tension on your vise, give it a tap, and come back up. And I think I went the wrong way. So, long story short, playing with that, you can square the piece of stock up perfectly. Alright. Let's see. What's another good example? Oh, finding the center of a circle. Or the outside of a circle, since we already have this in here. I have some really nice gauges that, indicators and stuff that I keep in the cabinet over here so they don't get dirty. I don't use them that often unless I'm really trying to get precision, but I have, if I can get back here where you can see it, probably need to zoom out. I got a nice center gauge that fits in the chuck, and you turn the machine on, it slowly rolls the indicator needle around the outside or inside of your part, and by moving the axis you can zero it up. If you measure, let's say, if I measure one side of the y-axis and the other side of the y-axis, then I can divide that measurement in half and still find the center of that distance. So even if, without being ridiculous, let me come up just a little bit. I'm trying to work the camera, even if say for instance, even if I'm not dead center this way, if I come in with my pointer and I touch here, as long as I have not moved X and I zero it, I raise up and I move over and I come back down and I touch here and I see what that distance I traveled is. If I come back exactly half, that will be half the distance. It's still the same as half the distance from here to here as it is from here to here, or here to here in the center this way, as long as you did not move X. If you move X, then you've changed the radius here. So let me show you real quick how I would center this up. Might as well go ahead and do it. I'm just going to try to find pretty close to the center of it eyeball. Come down. And like I say, there's so many ways of doing things. Put a little black on here again, so I can see when it touches. And now I can be a lot more accurate with this if I actually want to go into step mode, which is the right way to do it. But what I'm going to do is I'm going to just slow the feed down so I don't have so many steps to go through. You would normally go into step mode and step 1,000 at a time, but just to save a little time, I'm just going to slow the feed way down. Move the part till it touches. Slow it down even more. could have done it faster in step mode. Alright, at the very bottom you can see that it just touched the ink. At that point, I want to 0Y. Speed up, pull the axis up. Look to the other side. Back down. Oop. Yeah, 0. Gotta slow down a little bit here. Run back just until it touches again. There, it just touched. Now, whatever the measurement is reading on the y-axis, which is 2.754, we want to divide that in half. That'll be 1.377. So I want to raise this up. And move it to 1.377. Okay, I'm on 1.377. At this point, I'm on a 0 the y-axis, and I'm now in the center of it. Now I do repeat the same thing for x. Speed up a little bit. Take it till it just touches the pin and 0 the axis. Alright, just touch. 0 the X. Raise it back up. Go to the other side. Let it back down. Slow it down. Move it over until it just touches. Okay, right there it just touched. Whatever it reads on the x-axis, I have to divide in half. It's 2.746 divided by 2. That's 1.373, so I raise the axis up. Move back over to 1.373. And then 0 the x-axis. Now within relative accuracy, I'm now dead center in x and y and square on this piece of round stock. You would do the same thing to locate you could do the same thing to locate the center of the hole. All right. What else can we go into? Okay, when I was working with the jigs for the part I just made, shut this off so there's not so much background noise. I hate to pause this thing, but let me run this up. Some of the questions were how I relocated zero once I got the part back in the jig. And I started out, the reason I went through the process I did with the jig was that once I got it in the jig, see if I'm anywhere in view, probably not. Okay, back out here. Hey, if these aren't educational, at least I hope there's somebody you can make fun of. Gotta have a little fun. Okay, the reason for this jig is, hold on just a second. I gotta hit pause. Alright, I'm back. Okay, here's a piece of stock, the same as what I started out with to cut this out of. And the way I started out was, this layout, I measured the stock's width and height and width, okay. I drew a box around this in the drawing so I know its full width and height. And then with a scribe, I mark, it's kind of hard to see probably, let me see if you can see that. With the scribe, I mark them, scribe marks on this block on both sides. Okay, and they were better the other day, but this is all scratched up now. But there is a scribe mark in each corner. Now the reason for that is one time this jig is going to be holding this part upright this way, okay, and then the next time I'm going to rotate it over this way. Okay, at the first point 0, 0 is here, but since I want to always zero off the same point, when I flip this part over, it's not unbolted, and it's actually held level by, these are perfectly square, it's held level by this, and this is the 0, 0 point. When I flip this block, then I have to move the 0, 0 point from here to here so that I'm still zeroed within this end of the part. I hope that makes sense. I said that before when I was doing it in a drawing and I was putting the little boxes down there for where 0, 0 is. Now, the first thing that got cut out on this part was the bottom, and of course it didn't sit down in here. It actually sat like this, and this was mounted sitting in here on parallels. And I know they're too high, but they're just close enough. Okay, so it's sitting in here on parallels. I come in with a, to locate this point on this piece of material once it's bolted to that jig, if you've ever had one of these tiny little drill bits that there's no way you could ever drill a hole with, and I'm sure everybody's seen these, but find out where I'm at here. They're just a tiny little drill bit. I think this one was like 15 thousandths. Go ahead and snap it off because it's not worth a damn for anything else anyway. Unless you're a clockmaker and know how to use it. I'm too much of a bull. Put that in an 1/8 inch collet and just hand tighten it. Now, I'm just trying to find the general area on this block. So let's say this is bolted down. This is how the lower base of the jig is now square in the vice jaws. I want to come to this point here and zero the machine. So it just so happens this little point is exactly the width of a scribe mark, believe it or not, and it works so well. I would just bring the machine down to that point. Move it over. Now you have to make sure this block is perfectly square when you do this, because you mark both sides of it. Now slow way down. Now obviously I'm not going to get that critical on this, but then I got to move back. Bring that point right down into that intersection of those two lines. And then zero the machine. Now, at this point, you would think you could just put a stop in the chuck here, so that when you flip this around to do the other side, that you could put this block back against the stop. In an ideal world that would work, but there would have to have been some sort of alignment pins besides the bolt holes holding this to this block, because just the slop in the actual bolt holes would throw that theory off. So that's why zeros are marked on all the corners by scribing the entire block. Now when I take this out to flip it over, let me speed this thing up so it gets out of the way quicker. Alright, now when I take this block out, the first thing I did was I machined the bottom of the part. And the reason I machined the bottom of the part and it looked like this was so that once it's put in this jig and bolted in, then all the cuts that actually are critical as far as where they're located are all dimensioned off this line. And I'll show you what I mean, because there's no dimension down here height wise or location wise that's critical. The 4 bolt hole locations are critical as to far as the height here and the distance apart here. I hope this is making sense. So I machined the bottom first, so that once it's mounted in the jig, then everything is going to be cut square to the jig. Okay, so that was done first, and then this will fit that way. Okay. Now, when I did this, since this is square and this is square, I set these down. I opened the vise, set this in the base of the vise, put shims against this side to hold it straight in line with this one, and then I tighten these 4 bolts. So I'm relatively squared up in it this way. Alright. Now once I've turned this over, you'll notice that I've moved 0, I machined it this way, and 0 was here. When I flip this over, the 0 is now located over here, and from this point on, I work this side 0 from here. So do the same thing with this little point. Move it over here, get it zeroed back up on that, and then I machine the top, and that will then line up with everything on the bottom. Now that would mean that looking at this straight on, I have all the downward cuts. These are square still, but all the downward cuts and the pockets, and you can see where I screwed the pocket up. It's too wide. Yeah, measure twice, cut once. But okay, so that's all squared up. Now when I take this jig, and this is actually cut out on the outside now. Now when I take this part out and it's still on the jig, let me put it back on there. Put it on there real quick. So everything was machined sitting like this, and all the downward cuts were made. At this point now I need to cut these radiuses in here. So I need to flip this part up. So to do that and hold it in alignment, I made this plate. And this plate here bolts to the back of this one. Now this plate has to be shorter than the depth of the vise, and the reason is we're squaring off these surfaces off both sides. So this just has to be bolted to this. And it's just more or less a brace. It's not squaring anything up except for upright. Snug it. Alright. Now when I come in, this is sitting on the top of the vise jaw, which is level. And at this point I clamp here. Alright, now to find Z height and X and Y, I got ahead of myself here, and let me, let me back up just a little bit here to try to gracefully get out of this. Alright, there's 3 positions I need to find on this part so I'm accurate, and it's not in the jig right or anything, but that's alright. One measurement is, as you remember, I moved 0 from this end of X to this end of X. Well, when this was machined from the top in the jig, it actually machines the standoff itself. It machined this standoff itself. Also here there was a standoff on the top. I just bolted this on the block upside down, or the standoff would be standing there. So that standoff gives me a position to come down and touch off without doing anything to my part, to touch off on the top of the Z for setting 0. I would use my pin with the ink on it and come in and touch off against this standoff, which will give me my X 0 point, by deducting half the radius and moving back over. But my Y position point was actually measured before I put the part back on here. And the way I did that was to make sure that the distance from here to the center of these holes stays the right distance. If you look in my drawings, you'll see that I don't have anything good to point with. The top of this standoff, where this is bolted on, is 3/4 of an inch exactly below this top surface, which is 0.883. So to find 0, okay, since we're zeroing down off this corner, I know that if I could either touch it here and then deduct 0.883, or I did it with, before this is on, okay, I came in and touched the top of the actual standoff, alright, moved over half the diameter of the pin, and literally typed in, instead of hitting 0, you can type in the numbers of your location in Mach 3. I typed in 0.750 and hit enter. Okay, and that automatically made that 3/4 of an inch below this surface. Now, I hope this is making sense and I'm not garbling it up. So now I've established X is 0, Y is 0 from the bottom, Z is 0 by coming down and touching the standoff. Okay, when I flip this back over now, I only have to find X's axis. And when I flip it over, which would mean unbolting it from the block, loosening the block, flipping this over, now I have to come in and zero from this side and touch this standoff. And then when I touch this standoff, I move over 1/8 of an inch, the radius of the pin, and I 0x, and everything else stayed the same. So that kept this dead in line, and these two holes dead in line with these two holes and all these radiuses. So I was going to go into how I change tools. I don't know anything about any of this software, anything I use, believe me. I only look up what I need when I need it. I didn't read no manual. I didn't go to no school. If I need to know how to do something, I look that up. With my memory at my age, I forget more than I could read the whole book, and tomorrow I wouldn't be able to tell you I read the book. So, one of the things that I do though is, let's say if I got a project that's going to be multiple cutters, and you can set up tool tables and all that, and which is a great idea if you're a production shop and you're going to do a lot of work and you want just real quick tool changes, and you got your auto tool changers and all that. Well, in my case, I actually need a little bit of a break to make sure I'm thinking about what's going on here before I hit the go button. So let's say, for instance, I'm going to have a set of operations that are going to take several tools on this one block here, and this is all fictional, but I'm just going to set up tool number 1. And the way I do this, if you have a CNC machine that you have a quill, and you also have your Z-axis is driven off the dovetail. If your Z-axis is driven off the quill, you can't do what I'm about ready to show you. If your Z-axis is driven off the dovetail itself, then you have the luxury of still having the motion of the quill free. And you can put the quill, hopefully that's showing up. Nope, let's get it where you can see it. I'm just talking away, pointing. Now I hope some of this stuff's getting in the camera. You have the ability. Alright, got the quill in gear. I gotta get this little pin out of here because this thing will tear you up. I don't need anything. Okay. Let's put the first tool in there. Back up. Find my button. Alright, let's say this is my first tool. Now, normally, let's start the first tool with the shortest. Wouldn't want to start it with the longest. No, I want to start it with, sorry about that. Like I said, I gotta write a script to do this and not get it right. Okay, so we're gonna move back. We're going to ink a spot on top of this, and I'm going to move down, let's say 1,000 step, 1,000 step, 1,000 step until I just see it touch that ink. And when I see it touch that ink, I'm going to 0 Z. Okay. At that point in time, I'll do everything that I need to do with that tool. All right. But then, let's say I need to go to my next tool. So the way I would do that is, I've done everything I need to do with a 3/4 inch cutter. So, and it is zeroed at the height it is right now. To change the cutter, first off, I didn't mention this, make sure the cutter is buried all the way in your collet. Okay, so that when you go to put it back in, you bury it to the bottom of the collet. Okay, now for all the rest of the tools, they're set off of this one tool. So for me to change tools now and get it back to 0, I'm going to come to this block here and I want to get pretty close to 0. Well, that's pretty close because I had it a little fast. Okay, I'm a couple thousandths off. Okay, I'm going to 0 that z-axis just to show you what I'm talking about. And what I want to do now is move out to this block. Now I need speed. And it's just a piece of scrap that I don't even care about the thickness. But what I want to do here now is come down, same thing, ink on top of it. When I actually see it touch, say like right there it touched. I want to write down what Z says right now. And Z says 0.797. I want to write that down. Okay, so the cutter now is touching that block at 0.797 below where we had it zeroed on this. To go to my next tool, all I have to do now is raise the axis, get some speed, raise the axis high enough to get the tool out and the next tool in. Remove the tool, put in my next tool, and in the manual data entry screen, tell it to go to 0.797 Z, no, we'll go G0 Z negative 0.797, right? 797. Okay, see the difference in the two tools is made up with the quill. So you just move down till you touch. As soon as you touch, with gentle pressure, lock your quill. Now you're zeroed. Pick Z up. Y over. And I can type in Z0 and I'll be right on it. And each tool I can do this by just taking it constantly back here and typing in, telling Z, ordering Z to go to negative 0.797 and then using the actual quill to bring the tool to the touch point and locking it. So right now I'll tell Z to go to 0. And it's just like my last one, just barely touching the top of the plate. So, I mean, with a little practice, you can get pretty close. That's not perfect, but it is a speedier way to do it. If you don't want to actually ink and mark and touch and do that every time, this does work with a little care. So, I guess that's about it for this video. I know there's probably a bunch of stuff I missed and probably a bunch of stuff that didn't make any sense, so if anybody has any questions, feel free to ask, and corrections. I don't mind being corrected at all. I'm trying to learn. So everybody have a good day until I think of something else to record. Bye.